On this one, we're going to find the expected value e of x and the variance with a random variable x with the following probability distribution. Okay, let's talk about the formulas for each of these. Now there's a formula for e of x, they call that expected value. That's technically the same thing as the average mean mu for the probability distribution. And the calculation for that goes the summation x times p of x, where x represents the values here in the column, first column I should say, and p of x are all the probability values in the second column. The way we're going to think about expected value, and another way of thinking about it I should say, is we're going to take each value times the respective probability, adding them all together. So value times probability plus value times probability plus ... and so on from there. The variance of x, sometimes in the textbooks they like to abbreviate it as VAR. I usually don't do that. I use the notation sigma squared usually. And that's like standard deviation, but raised to the second power with no square root. And the variance formula for a discrete probability distribution goes the summation x minus mu in parentheses squared times p of x. So we're going to do both of those calculations here. Starting with expected value, that means I'm just going to go through, take each value times the probability, so -1 times 0.25, added with 0 times 0.40, plus 1 times 0.05, plus 2 times 0.05, plus 3 times 0.10, plus 4 times 0.15. So we just went through, multiply value, probability, plus value, probability, plus value times probability, and we calculate that all out to get an expected value, or average mean, for the probability distribution, mu, equal to, in this case, 0.8. With that number in mind, we're going to calculate the variance. Okay, to calculate the variance here, what we're going to do is start by doing x minus mu, each of those subtractions raised to the second power. Here's our values for x. We're going to subtract away the expected value, or mu in this case, same thing, of 0.8 from each of those. And then we're going to square that value. So you could plug this in the calculator step by step in parentheses to the second power and see what you get from there. The numbers I received look something like 3.24, 0.64, 0.04, 1.44, 4.84, and 10.24. Now each of those values, in the next step, what we're going to do is multiply those by each respective probability value, p of x. So you have to look in the table at the probability values that go along with each of these numbers here. So for the first one, that was 0.25, and then 0.40, and so forth. Okay, let's do those, multiply those together, and see what we get. I got numbers like 0.81, 0.256, 0.002, and so forth. Okay, and then the last step in the variance formula is to take the sum of all these things. We do the sum x minus mu squared times p of x. So the sum of all of these values put together here. If we add all those numbers up together, we'll get a total of 3.16. And that's our answer for the variance. Here's another question which involves the expected value. It says there's 1,000 tickets are being sold for a raffle prize, and there are one $300 prize, 2 $100 prizes and 100 $1 prizes. What is the expected value of the ticket? Well, again, the expected value, E of x, is defined in the formula as the summation x times P of x. But what does that mean in the context of this particular example? Well, again, it can be thought of as taking the respective values times the respective probabilities, plus and adding them all up together across all the different outcomes here. So we have to calculate the probabilities to go along with it here. We know the values though. For instance, there's $300 value times the probability of that particular outcome, plus, well, we have $100 times the probability of $100, plus $1 times the probability of winning $1. Okay, and so we can do that here. $300 times the probability of winning the one $300 prize is 1 out of 1,000, because they sold 1,000 tickets. So 1 out of 1,000 plus 100, and the probability of winning a $100 prize, there are 2 of those out of 1,000, plus $1 times the probability of that happening, which is there's 100 of those prizes out of 1,000 total tickets. So what we're doing here is really 300 over 1,000 plus 200 over 1,000 plus 100 over 1,000, which would be equal to 600 over 1,000, or expected value of 0.60 or 60 cents.